show that this whole thing equals this whole thing. Okay, when I have to show something, I cannot work this side and this side with the equal sign in between. So what I'm going to do is I'm going to work with my left-hand side. Okay, and I'm going to try and solve this. Now I'm not going to do a little thing for each of this. I'm just going to have my one cast diagram here, and we'll work from there. This is 0. We're working in degrees, so I'm going to say 0, 180 degrees, and so on. Okay, so this is 90 degrees. This is 270 degrees. So what I do is I start with the sine of 90 plus. I say sine of 90 plus. 90 plus is, let's just quickly cast this. Cast. So what I'm going to do is I'm going to say the sine of 90 plus theta is in my third quadrant. So it's going to lie there. In my third quadrant, sine is positive, but I'm working from my y-axis. And when I work from my y-axis, I work with my complementary function. So sine becomes the cos of alpha. And it is definitely positive because sine is in my second quadrant positive. That will be divided by 1 minus sec alpha. Plus the sine of 90 minus alpha. If I say 90 minus alpha, it's back into my first quadrant. In my first quadrant, everything is positive, so that's why it stays positive. I'm working for my y-axis, so I work with complementary angles, so it means sine becomes the cos of my reference angle alpha. Divide by 1 plus sec alpha. This equals, I'm going to get my lowest common multiple, which is going to be 1 minus sec alpha, 1 plus sec alpha. Means I have to multiply cos alpha with 1 plus sec alpha plus, and this side I have to multiply cos alpha with 1 minus sec alpha. If I multiply this now out, cos alpha times that is cos alpha. This is going to give me plus cos alpha sec alpha. Plus this is going to give me cos alpha. That's going to give me minus cos alpha sec alpha. Divide by 1 times 1, this is the difference of 2 squares. So this is 1 minus sec square alpha. Okay, now cos alpha sec alpha, take away cos alpha sec alpha, gives me 0. They cancel. This take away exactly the same thing as 0. Cos alpha plus cos alpha gives me 2 cos alpha. Now this bottom one is 1 minus sec square. Now I know that sec square is actually 1. I know my Pythagorean theorem is that sec square equals 1 plus tan square. Okay, so I can say that this is 1 over 1 minus, and sec square is 1 plus tan square alpha. Okay, so sec alpha is 1 plus tan square of alpha. And then if I simplify that, I will get 2 cos alpha. 1 minus 1 is 0. Plus, and I'm left with tan square theta underneath the line. 1 over, I'm just going to write next to this. This is 2 cos alpha, and tan square alpha is the reciprocal of cot. So if that goes above the line, it becomes cot square alpha. This equal, oh, where's my negative? Oh, if I multiply this negative in here, so this is 1, take away 1, take away tan. So this should be a negative, which will make this a negative, and therefore this equals my right-hand side.